2.1. Follow along with me. We're only doing 3 slides today. We're going to do the first part today, second part tomorrow. What you guys need to know from here. When we talk about the domain of a function, does anybody know what domain is?
All the possible values that are able to be included.
Yeah, all of the possible inputs. Good. Domain is all of your inputs. Range is your output. Domain is our x values. Right? We're going to determine the domain of possible domain of functions here. It's what can I use for x? What can I plug in for x in my equation? You will have some restrictions, and we're going to talk about when you have restrictions and what those look like. When you write your domain and your range, it needs to be written in interval notation. We already know what that looks like. We had to do that on our last 2 quizzes and tests. But you're going to write domain and your range in interval notation. So if you were given this parameter, if they said to you, this is the domain between what and what. If I said to you to write it in interval notation, can you guys do that? Yeah. What is it? Bracket 0, comma 5. What? Bracket. Okay, we're going to be doing some things where you're going to have to solve for x and that sort of thing and then write the domain. If you don't see it when given an inequality like this, you could just graph it on a number line real quick. If I graph this on a number line, do you guys agree with me? I have 0 and 5. Both of my dots here are closed, right?
How do you check it?
Well, this isn't something that you would check. I'll show you how to check stuff later, but I'm just saying if you're given this, or if this becomes your answer, do you know how to write it as interval notation? But since x is in the middle, you would color in the middle, right? That's what that's saying. So what we're going to do now is we're going to talk about when you would have domain restrictions. This slide is extremely important. All right? It says domain of a function is all real numbers. How do you say all real numbers in interval notation? Negative infinity to what? Positive infinity, right? The domain of a function is all real numbers, anything in the world, unless your function breaks one of these rules. So when we do our problems, when we do our homework, when we practice, you should have these rules right next to you when you're doing them, because you won't have them on the day of the test. But the 3 rules are as follows. Number 1, if there is a variable in a denominator, you have to set the denominator not equal to 0. Why is that? If I had 1 over x plus 3, is there a value that I absolutely cannot use here? I can plug in 0. What can I not use?
-3.
Why? But what happens when I plug in -3 here? What does my denominator become? 0. When you have 0 as the denominator, your function is undefined. It's not 0, it's undefined. So you have to figure out, when there's a variable in the denominator, you have to figure out, what number or numbers can I not use? Because if I plug them in, my denominator becomes 0, which means my function is undefined.
Wait, but if you set it equal to 0, then...
You set it not equal to 0. Mm-hmm.
Whenever there's a fraction, you can't have 0?
The denominator cannot become 0.
Okay.
So you have to figure out what would make it become 0. The second rule is if there is a variable underneath the square root. You have to set your expression under the root greater than or equal to 0. Well, why is that? If I have the square root of 2x plus 1. Very good. It has to be greater than or equal to 0. And Aiden just said it has to be greater than or equal to 0. Okay, good. I'm glad you asked that. Why does it have to be greater than or equal to 0? Okay, can I take the square root of 5? Yeah, you can. Is it a pretty number? No, but you can still get the square root of 5. Can you take the square root of 0?
No.
What's the square root of 0, guys? 0. So you can take the square root of 0. Bye, sweetheart. Can you take the square root of -2? Why not? Because it's It's an imaginary.
Wait, so technically
You cannot not get a real answer. We're talking about real solutions, real answers. Your domain, look for the set of all real numbers. So whatever's underneath the square root has to be greater than or equal to 0. It can be 0, but it cannot be less than 0. So that's the rule. The third rule is kind of a combination of the first two. If there's a variable underneath the square root and it's where? It has to be set greater than 0. How is this rule a little bit different?
It can't be 0.
It can't be equal to. Good. Why can it not be equal to?
because it can't be 0.
Perfect, because your denominator cannot become 0. So do you see the difference here, guys? In interval notation, what is the difference of this sign versus this sign? Brackets and parentheses. Good. This one would use a bracket and include the number. This one would be a parenthesis and not include. Very good.
What do you mean by that?
What do you mean by what do I mean?
I can include the number and not.
Like, well, I'll show you an example in a second. So these are the 3 rules that you guys need to be super, super duper aware of. So let's look at it. I'll upload this. Some examples here. If you notice, I just screenshot the rules and I put it right next to it so I could refer to it. Make your B look like mine. Your letter B needs to look like mine. Now, this is what you'll have a question or two on your test, and it says state the domain, write your answer in interval notation. So it's what can X be? What can I plug in for X? So go through the rules. Let's do A together. We'll do them all together. But let's look at A, okay? A, f of x equals 1 over x squared minus x. Look at rule number 1. If there's a variable in the denominator, are we breaking that rule? Yes. Where is the variables here? They're in the denominator. So what does it tell me to do? If the case arises where there's variables in the denominator, what do we do? Set the denominator not equal to 0. So you literally write x squared minus x cannot be 0. Now we go back to what we've been doing from the very beginning. If we're going to solve this, I have x squared and an x. We're going to factor. So what do I take out first? What's the GCF between x squared and x? X. So take out an x. And I'm left with x minus 1. Cannot be 0. Agreed? Now what do I do with each of those little pieces? I set it not equal to 0. Whoops. So x can be anything in the entire world except for 2 numbers. What are those 2 numbers that x cannot be?
0 and 1.
X cannot be 0, and x cannot be 1. I totally agree with that. Now, when you are answering this question, it's going to say, tell me the domain, and write your answer in interval notation. This is where our graphing comes in handy. Put this on a number line. All right, some of you can see this right away, no problem. Some of us can't. So would you agree with me? 0's here and 1 is here, right? What kind of dots would I have at 0 and 1? Why are they both open? Because it can't be those. But it can be everything else, right? It can be anything over here. It can be anything over here. And are there numbers in between 0 and 1? Yeah. So interval notation. What is my domain for this function? How would I write it?
0 and 1 parentheses.
Well, what's over here?
Negative infinity 0.
So I can go negative infinity all the way up to 0. U. Then where?
1.
0 to 1.
Ooh, 0 to 1. Good, Gio. 0 to 1. And 1 to infinity. You just told me right here that you can use any numbers in the world except for 0 and 1. How did I show you with my interval notation that you can't use 0 and you can't use 1? Because they're parentheses. Yep.
I don't understand.
Hey, you can use anything on this number line except for 0 and 1. And by writing this with a parenthesis, you're telling me, ooh, 0 and 1 are not included. Everybody see that? All right, let's look at the next one. Let's look at B. We're going to do B together. All right, B. Your B should look like mine. Change it. So look at your rules. Number 1, is there a variable in a denominator?
Wait, no.
No. Okay, so rule number 2. Is there a variable underneath the square root? Yes. So what does it say to do if you break that rule? Set the expression under the root greater than or equal to 0. So 9 minus x has to be greater than or equal to 0. How do you get that square root to go away? Okay, I square one side, then I square the other, right? Well, 0 squared is just, so 9 minus x greater than or equal to 0. Now what? Subtract 9. Negative x greater than or equal to negative 9. Divide by negative 1. What do I do when I divide by negative 1? You flip the inequality sign. Great. So negative 9 divided by negative 1. Yep. So now I'd say, okay, well, what's the domain? Well, if you guys are just like, oh, I'm not sure, put that on a graph. Here's 0, and here's 9. All right, what kind of a dot would I have at 9? Closed. And it says x is what? Less than or equal to. So I'd color which way? So how would I write that if I'm asking you for the domain in interval notation? What are the values that I can use here? Negative infinity, comma 9, what? Perfect. That means, can I use 9? Yes. Now, Gio, you just asked a little bit ago, how do I check it? So let's check, all right? Our original, right here, I just don't want my underneath the square root to be less than 0, right? So plug in a number to the left of 9. Plug in negative 1. What's 9 minus negative 1? 10. Square root of 10. Is that a positive number? We're good? Yeah. Okay. Plug in 0. What's 9 minus 0? 9. Square root of 9 is 3. Okay, we're good. Plug in 9 itself. What's 9 minus 9? 0. Square root of 0 is 0. Okay, we're good. Plug in something to the right where I didn't shade. Plug in 12. What's 9 minus 12? Negative 3. What's the square root of negative 3?
3.
No.
Oh, wait.
It's got an imaginary in it. So it should not be in our graph, which it's not. So your domain is you can use anything in the world from negative infinity, but you have to stop at 9. Because if you do anything above 9, it'll make a negative underneath the square root, which you can't have. Yes, ma'am. All right, 2 more. Let's look at C. Let's look at our rules. All right, first rule. Is there a variable in a denominator? Yep. All right, so I should set the denominator not equal to 0. Read your second rule. Is there an expression underneath the square root that has a variable in it? So it's breaking both of them, right? Do we have a rule that's a combo? Yep. Number 3 is if it's doing both things wrong. Do I have a square root with a variable in it? Yes. Is it in the denominator? Yes. That means we're breaking rule number 3. So what does it say to do if you're breaking rule number 3? Okay, so you're going to set the expression. I'm going to use x because my t's look like plus signs. Greater than 0. Remind me again, guys, why is it not greater than or equal to?
Because it's in the bottom.
Because it's in the bottom. Good. And the denominator cannot be 0. Very good. So how do we solve this? Super easy.
Can't you just tell what it is just by looking at it?
Kind of, but some of them are going to be a little more complicated. So we're going to square both sides, right? So x plus 1 greater than 0. And yeah, you can tell a lot of the times, but I need to see your thought process. So make sure you're doing this. So I'm going to subtract 1 from both sides. I get x greater than negative 1. Now, if you can't look at that and just tell me what the domain is, that's perfectly fine. Take 2 seconds and put it on a graph. What kind of a dot do you have at negative 1? It's open. And that says x is what than negative 1? Which way is greater than? To the right. So how would you write the domain for this problem? Negative 1 comma infinity. Does it include negative 1? No. Let's check just to make sure we're right. Okay? We cannot have a negative underneath the square root, and our denominator cannot be 0. So if I plug in negative 2, should negative 2 work? No. So if I plug negative 2 in here, what's negative 2 plus 1? Negative 1. Then the square root of negative 1 is imaginary, so we're good. Should negative 1 work when I plug it in? No. When I plug in negative 1 plus 1 is 0, but the square root of 0 is... And 0 can't be in the denominator. So I can use everything that is bigger than -1. So your domain would be -1 to positive infinity. And you're telling me right here that it doesn't include. And how do you know it's not included? Because it's what kind of a notation? It's a parenthesis. Good. All right, so don't be fooled on D. Let's do D together, and then we're done. D says f of x equals 2x squared. 2x squared minus 3x plus 1. All right, so let's go over our rules. Rule number 1. Is there a variable in the denominator? No. Okay, so we're good there. 2. Is there a variable underneath a square root? No. Nope, we're good there. Number 3. Is there a variable underneath a square root that is also in a denominator? No. Am I breaking any rules? Do I have any domain restrictions at all? No. So how would I say that? How would you say, Mrs. Meadows, just plug in whatever number you want, doesn't matter. Negative infinity to positive infinity. I can use any negative number in the world, and when I plug it in, I'll get out an answer. I can use any positive number in the world. When I plug it in, I will get out an answer. I can plug in 0, right? And I get out 1. So your domain here, if none of your rules are broken, your domain is all real numbers, negative infinity to positive infinity.